So we discuss apparent depth and real depth. Apparent depth and real depth. Apparent depth and real depth. Yes. Case 1. In the first case, object is kept in denser medium. It is viewed from a rarer medium. Then it appears to be near the surface of water. It appears near the denser medium, surface of the denser medium, Say for example, this is a boundary that separates two media, that is called air and water. A fish is in water. See now, this is a fish. It is in water. A fish is in water. This is an object. One light ray is traveling like this. This is called point of incidence. OP is point of incidence. Just drop a normal here. And this could be a reflecting light, because the ray is traveling from rarer medium into denser medium into rarer medium. So it must bend away from the normal. It's bending like this. Just take this way. It is extended in the backward direction. So this appears to be at O prime. Refracting ray is going like this. This is called angle of refraction. This is called angle of incidence. These two are vertically opposite angles. This is also called I. When this is R, this should be equals to R. Just name it A. APO is a right angle triangle. Is a triangle, right angle triangle. From this, tan I is equals to, what is tan I? Is equals to tan I. Opposite side AP by what? AO. AO is called real depth. The object is kept, fish is at a high depth of water. AO, real depth. Just I call it as, that is T. Similarly, tan R is equals to, from which triangle? APO is a triangle. See, earlier, now AO prime P. AO prime P is a triangle, right angle triangle. Tan R equals to, what is tan R value? AP by AO prime. So this is AO prime. What is AO prime? It is called apparent depth. Apparent depth, I call it as T prime. T prime is less than what? Very good. Now you see. T prime is less than T. This is T prime. I call it as T prime. This is T prime. This distance is T prime. This is T prime. This is T. This distance is T. Refractive index denser medium is mu. This is water. I just call it as mu. Refractive index of air is equals to 1. As I and R are small in magnitude, tan I by tan R is nearly equal to sin I by sin R. That should be equals to refractive index of air with respect to water, because refracting ray is present in air. That should be equals to, that is sin I by sin R. That should be equals to refractive index of air is 1 and refractive index of water is 1. Sin I value we have. This is of course called what? Sin I. This is of course is called what? Sin R. So therefore sin I value is equals to AP by O divided by sin R equals to how much? That is AP by AO prime is equals to 1 by mu. This AP cancel. AO prime by what? A equals to 1 by mu. AO prime, I said it is apparent depth. Apparent depth by what? Real depth. That should be equals to 1 by mu. Therefore, mu is equals to real depth by apparent depth. Is the most important formula, which is definitely greater than 1. Now shift. Let us calculate the shift also. What is shift? Shift is nothing but it is shifted from O to O prime. This is O prime. What is the shift? O prime is equals to how much? AO minus AO prime. AO value is T minus T prime is equal to shift is X. But this can be written as what? T by, that is, you can write this as mu is equals to T by T prime. Therefore, T prime is equals to T by mu. Substitute here. T minus T prime value is T by mu. Hence, T is common. 1 minus 1 by mu. This is called shift. It's the most important part. We calculated shift as well as what? Refractive index. Calculation of refractive index of denser medium and what? Shift. Refractive index mu and shift in the denser medium. Please note.